Good morning, Mr. Nice. Great having you here in Alden. Finally, I'm really glad your visit works after half a year. That's great and welcome in Alden. This is our new manufacturing hall. Please follow me over here. Here we have installed our MPAS for your demonstration purposes. This is a version we have already modified and prepared especially for your tensile samples. This autosampler is prepared for 30 samples. I'm sure you know this autosampler MPAS can be used for at least 4 different sample holder types without any user interaction. Tensile, compression, double shear and 3-point bending are the most important geometries. By the way, this system is unique in the world market. Normally, at least the MPAS is able to handle samples having a different length of 30 and 10 millimeters. Your sample have arrived us last week and 2 of them are already installed in the autosampler. Okay, now we are ready for a demonstration. Regarding to your rubber compounds, details about the glass transition temperature and the pain effect are the most important informations. Therefore, I propose to start with a strain sweep. We will receive information about the pain effect, followed by a temperature sweep showing the TG, the glass transition of your compounds. This should be done for 2 identical samples. I have prepared the test conditions already. Due to the fact these samples are from the same batch, we should expect for both samples very similar results for the strain as well as for the temperature sweep. Now we simply need to start the autosampler. Do you have questions?
Oh yes, I have a few questions. Of course, that's what we have agreed already. It's okay for me. I have written down my questions. Please wait a moment, let me look at my notes. Okay, first question. You told me 2 different sample lengths can be handled by the ASC. Are there any restrictions in width and thickness?
Normally not. A thickness from 1 to 4 mm and the width from, let me say, 2 mm up to 10 mm is possible. But I recommend samples with 2 mm thickness and 5 to 10 mm width. Normally in each rubber lab, plates having a thickness of 2 mm are available. The same is true for plastics or other materials. Don't worry, I guess this is the best choice.
That's really very clear. Okay, my second question. I guess I need to measure the sample dimensions for all samples before I'm feeding the autosampler with all my samples. Is that correct?
A good question. The answer is yes and no. Normally the thickness of the sheets used for the sample preparation is fixed due to the vulcanization process itself. It's normally about 2 mm. Depending on your cutter, you will get a final geometry, for instance 10 mm. This means the cross-section should be fixed. I mean, this is 2 mm by 10 mm, okay? But unfortunately, the sheets do not show a constant thickness. It could vary from, let me say, 1.8 to 2.2 mm, sometimes even more. Therefore, I guess it makes a lot of sense to measure the thickness of the samples before the test. The same should be done for the width. Some material flows and the width can become wider than the dimensions of the cutter. The good news is, even if you have forgotten typing in the correct dimensions before the test was performed, the software allows to type in the geometry afterwards, even if the test is over.
Okay, I understand. This seems to be acceptable for us. Please, one last question. Of course, only for the moment. I guess I will have more questions later on. You never know. I know from my existing DMA, after cooling down to a sub-ambient starting temperature, for example, minus 100 degrees, it is mandatory to open the furnace and tighten the screws of the sample holder again, because the sample becomes loose at low temperatures. I guess this must be the same problem for the Eplexor and the ASC. Am I right?
A good question. But this is not a problem with this system. The holder are designed as self-tightening systems. There is no need to open the doors of the temperature chamber at low temperatures and tighten the holders again. This would be not very convenient and will not work for an automatic system. I guess this is quite clear. Okay, let's start the run. Now let us look for 2 full cycles of the MPAS. During the first step, the magazine is moving to its starting position. If the starting position is achieved, the robot arm moves forward and is picking up the corresponding sample in the sample holder. Now the robot arm is turning by 270 degrees and is inserting the sample holder with the sample, in this case a tensile sample, in the corresponding receptacles inside of the temperature chamber. Now the arm removes and turns back to his rest position. Now the computer is preparing the test. Let's take a look on the screen of the monitor. Now the online graphic appears on the screen. The instrument itself is preparing the static and dynamic load conditions before the system is executing the first data point. Here is shown a time sweep with in total 5 data points. Now we are expecting the first data point of this time sweep. Okay, now the data point appears. Number 2, number 3, number 4, and now the last data point. Now the test is over, and the robot arm moves around from his rest position and moves into the front of the temperature chamber. Right now, the system is picking up the sample and moves the sample back into the magazine of the MPAS. Okay, now it's coming out, is turning around, and the sample comes back to the original magazine. The second sample was installed on the top of this magazine on the roof. Here we have 10 levels. Now we have reached the 10th level and the arm has already picked up the sample from the magazine. And now the arm is turning around to install the sample in the temperature chamber. Here we are performing a temperature sweep, and that's the reason why at the end of the day the auto sampler, the MPAS system, is closing the door automatically. No human interaction is required at that point. Everything is running fully automatic.